Welcome to Algebra and Trigonometry 1. This is the basic course in the mathematics of civil engineering technology. For those of you who have pre-calculus and stuff, this is a review. It is it's not terribly difficult stuff, but as we get deeper into the course, you will find that the material increasingly gets difficult. Now with Algebra and Trigonometry 1, there is a lot of material and it's not dependent on each other, so you have to pay attention to the work to be done. Algebra and trigonometry start off very basic and progressively gets more difficult, so that's something that you should be aware of. You need to be attentive and spend time with the work, right? So the content is always changing, as we'll see in chapter 1 section 1. The content is always changing. When we look at the content of chapter 1 section, chapter 1 itself, we have 12 sections to it, right? We're going to discuss numbers, basic material, fundamental operation of algebra, calculators and approximate numbers, exponents, scientific notation, roots and radicals, addition and subtraction of algebraic expression, multiplication of algebraic expression, division of algebraic expression, solving equation, formula, literal equation, and applied word problem. So this here, I would say it's the majority of work that we are going to be covering in Algebra and Trig 1. Right, and I'm saying the majority because we will be going over a lot of this in other chapters, right? This is an introduction chapter. It's an introduction chapter, and of course it touches on all of these, and then we go to other chapters and we build on it. When we look at this, we're starting into it now. What is a natural number? This is something that you know, but maybe you need a refresher too. A natural number is really a whole number that starts at 1 and go positively, right? So 1, 2, 3, 4, 5, that's a natural number. Well, whereas a whole number will start at 0 and it goes positively too. So the difference between a natural number and a whole number is just the 0. The whole number has the 0 involved. Now when we speak about 0, 0 is the dividing line between positive and negative numbers. Keep that in mind, but it is considered to be a positive number, right? So again, natural numbers start at 1 and increase, and whole numbers start at 0 and increase. They are integers, meaning that they're not partial number, they're not 1.5 or 1.5 or any, they are integers. When we look at integers now, integers could be both positive and negative numbers, right? It has positive integers, which will include the 0 and goes positively, and negative integers will be -1 and it gets smaller. Okay. When we look at rational numbers are a number that can be written as a fraction of integers, right? Remember what integers are. They're really whole numbers minus and plus, right? So you could write the number, if it could be written as a fraction of integers, then it is a rational number. Okay, when we look at 5/8, now that's an exact number also, meaning that there's no errors in there. It's just a number, and all the precision and accuracy is involved with that number. When we look at 11/3, it is also a rational number, and it's an exact number also. When we punch this into our calculator and then we round off at the end, then we change it from an exact number to an approximate number, right? Because we have introduced an error into it by rounding it off. When we look at 5, well, it's supposed to be a ratio of integers. How could we represent 5 as a ratio of integers? Well, it could be 5 divided by 1, it's still 5. It did not change the value. 10 divided by 1 is still 10. 15 divided by 1 is still 15. So these are all rational numbers. Rational number in decimal form now. Now, not all the time that you're going to have rational number presented to you as fractions, right? If you have a rational number in decimal form, how do you decide whether it's rational or irrational? Well, the way to do that is two rules basically. If the decimal number is repeating, right, 1.55555 whatever, right, if it is repeating, then it is a rational number. If it terminates, it stops by itself, then again it represents one of these numbers here, and it would be a rational number. When we look at this 2/3, 0.6666, this is a rational number, right, because of the repeating of it. Right. When we look at termination, we have say 0.5, it stops. It didn't repeat anything, it just stops, it terminates. So 0.5 is a rational number just judging by that alone. When we look at, I just did a little bit of a calculation in here. If we want to change this back to integers, we could multiply 0.5 by 10, and you have to divide. To keep the value of it, you have to divide by 10 also. So we have 0.5 times 10 will be 5, divided by 10, which will be 5 divided by 10, which is simplified form 1/2, right? So this shows that this is a rational number by just doing that. But the rules that you have to look at when you're looking at a decimal form of a number and trying to decide whether it's rational or irrational, does it terminate or does it repeat? Well, this one terminates, right? So it is rational. In most cases, rational number terminates, right? So when we look at this, this is a rational number, but when you go to decimal form, it terminates. So those are the two scenarios or the two rules that you should use for deciding whether numbers in decimal form is rational or irrational. When we look, rational numbers are positive or negative decimal numbers, so they could be positive or negative. When we look at irrational numbers now, when we speak about rational and irrational number, you only could be in one category. You're either rational or you're irrational. Those are the two conditions that you could have. Irrational numbers are numbers that cannot be represented, cannot be written as a fraction of integers, right? So rational numbers can be represented by a ratio of integers, but irrational numbers cannot. One of the most famous irrational number is pi, right? So we know that pi 3.1415926535897932384, and it keeps on going. We know that pi goes on for ever and a day, right? There are also other irrational numbers. The other irrational comes from roots, right? They come from roots. If you take the root of 2, you'll get a irrational number because it'll keep on continuing. You cannot represent it by a ratio of integers. You cannot represent this by a ratio of integers or that by a ratio of integers, and so on. You know, so then when we look at the roots of numbers, not all roots of numbers will turn out to be irrational. Say for instance we have 25 and we take the root of it, well, that is 5, and you can represent that by a ratio of integers, 5/1. So that would be, but these type of numbers, right, that goes on forever, those are irrational numbers. There are other famous irrational numbers such as Euler's numbers and the golden ratio and so on, but does not have a repeating pattern or terminate. So that's D's classification here, right? Roots of numbers that do not terminate, root of 13, root of 6, they don't terminate. Do not terminate, right? So if you punch these into your calculator, you'll find that they do not terminate. They keep on going and they don't have a repeating pattern, so they are irrational numbers. When we look at this particular kind of table, we have pi as an irrational number, we have Euler's number, we have the golden ratio, and we have roots of numbers, right? So those are the ones that are irrational numbers. Irrational numbers, numbers that are non-repeating and do not terminate. When we look at classifying these numbers here, we know that this is a rational number because it could be represented by a ratio of integers, so it is rational. When we look at this guy here, this is also rational. When we look at this decimal form here, the decimal form of this, well, it's repeating pattern, so it is rational number. And when we look at this guy here, it terminates, so it is a rational number. Okay, so we would have all of these as being rational. Let's go to another one. When we go to irrational numbers now, we know that pi is irrational. We know that root of 2 is irrational. If you don't know about this, just punch it into your calculator and look at it, right? When we look at this guy here, we know that this is irrational because it does not have a repeating pattern and it continues, right? It doesn't terminate. And this guy here, well, this one terminates, so it has to be rational. Okay, so it has to be rational. When we look at if a number is not rational, it is irrational. So it's one of the two classifications. It is easier to remember the definition of an irrational number. It's easier to remember the definition of a rational number, and then everything else is rational. The number that cannot be written as a fraction of integers, right, is an irrational number. Does not repeat or terminate. If it's in the decimal form, it does not have a repeating pattern, and it does not terminate. So those are irrational numbers. Roots of numbers that do not repeat or terminate, well, we said that already. What are common? They are commonly the roots of some number. They're commonly, irrational numbers are commonly the root of some number. When we look at this, we are looking at the real number system, right? We have the natural numbers, which we discussed already. It starts from 1 and increase positively as integers. When we look at whole numbers, that starts at 0 and increase positively. So the only difference between these two is the 0 for whole numbers. When we look at positive or negative integers, and these are all under the real number set. This classification of real number, there's real and imaginary numbers. So these are all real number sets. When we look at rational numbers, represented by the ratio of integers, this one terminates, this one has a repeating pattern. And then we have the irrational numbers, and all of these are the real number set. We have the root of 2, which will continue for a day and ever, and we have pi, we have Euler's number. So all of these are numbers that belongs to the real number set. Okay. When we look at this is another one, just a review, a summary of what we've covered so far. Natural numbers start at 1 and increase positively. Whole numbers are integers. And when we look at whole numbers, it starts at 0 and they're positive integers increasing, right? Integers could be whole numbers. Well, they're not partial numbers, put it that way. They're not partial numbers, and there could be positive and negative, whereas these guys are all positive. 0 is considered to be a positive number. Rational numbers, this could be written as minus 2 over 1, 4 over 1. This is already a ratio of integers. This is a ratio of integers. So that's where we're at. When we look at irrational, we're looking at pi here. And we look at 27, the root of 27. 1/2 power represent the root. And 5 to the 1/2, that would also represent an irrational number. Right? So those are just summary of what the past slides are. When we look at this real number system, all the numbers and irrational numbers, that is all the numbers that can be expressed as decimal, right? So when we look at that, all numbers are real numbers except for imaginary numbers. So again, we have we had rational and irrational. Now we have real and imaginary. So you either could be one of those two, right? When we look at this particular number here, how do we define what is an imaginary number? Well, the index that's understood here is 2. This is the square root of minus 16. This is the cube root of minus 16. And this is the 10th root of minus 16. The thing is that we have to examine is what we call the index. These numbers right there. There is an understood 2 right in here. This is a 3. If the index is an even number and the radicand is a minus number, then you're going to have an imaginary number. And you should try this with your calculator. Take minus 16 and take the root of it, and your calculator will try to say something to you by giving you an error or a coordinate set or so. What it's trying to say to you is, this is not a real number, right? So you should, well, however, when we have an odd root of a negative number, it's a negative real number, okay? And you should be aware of that. If you have an even root, these two will be imaginary. This one will be a negative real number, okay? Let's go and look at that. When we look at this, punch it into your calculator, you will see that this comes up with an error. This guy here will come up with a real negative number. And yeah. Okay, let's go to the next slide. Imaginary numbers are even root of a negative number. So all of these three here, they have an understood 2 that's there. So that's an even index. That's an even index, so it's an even root. When you punch this in, it'll be imaginary, this will be imaginary, and this will be imaginary. It doesn't make a difference. These will be imaginary numbers. If the index is even and the number is a negative, then the result is imaginary. If the index is odd and the number is a minus, then the resulting number is a real negative number, right? So we have all even index, so all of these are imaginary. Let's go and look at this guy here. Let's go and classify it. When we look at this, 0, is it a whole number? Well, yes, the whole number start at 0. It's not a natural number because its natural number doesn't include 0, right? So we know that whole number start at 0. Is it a rational number? If we were to divide this, say, by 1, okay, you'll end up with 0, so it is a rational number. And then when we look at, is it an integer? Yes, it is, right? It's that dividing point between positive and negative. Is it an irrational? Well, you cannot be rational and irrational, right? You have to be one of the two, so it cannot be this. Is it a real number? Yes, it is. It's a real number. And if it's a real number, it cannot be an imaginary number, right? So these are the things that you have to keep in mind. Let's go and classify this. We already know that this is an irrational number. We know that because if you punch this into your calculator, you will see. Is it a whole number? No. Is it a natural number? No. Is it a rational number? Right? No. Is it an irrational number? Well, it's not an integer, so it is an irrational number, right? So we know that that's where it fits the classification. Is it a real number? Yes, it is, right? And that means it's not an imaginary number, right? So that's where we're looking at that. When we look at this one here, classify the following numbers. When we look at this, we have -6. Is it a whole number? No. Whole number start at 0. Natural number start at 1. And this is negative. And we have, is it rational? Yes, it is. Is it an integer? It's a negative integer, right? Is it irrational, right? Does it no, it's a rational number, so it cannot be irrational, right? So is it a real number, right? We know that it's not imaginary, so it has to be real, right? And that's all the classification that we have. This guy here just fits on this classification. Let's go to, and I know that this is a little bit simple for this level of mathematics, but I'm going to explain it anyhow because it is part of what you might run into in your homework online. When we look at this, we have a number line, and of course the origin is right here. It's the dividing point between positive and negative numbers, right? So when we look at this, we're going to go and plot these numbers. Positive 5 will be end up over here. We have 0 end up at the origin. We have -3 will end up right there. Oh, -3 is end up right there, not on the other side. That would be the absolute value of it. And 4 will end up over here. And we have -7, which will be somewhere in here. Right, so those are how we plot those. Let's go and look at absolute value. Absolute value. The positive number is the number itself. So if you ask for an absolute value of a positive number, it's that number itself. The negative number, it is the corresponding positive number on the number line. So let's go back one here. Let's go back. When we look at the number line, if I wanted the absolute value of -3, it would be +3, right? So that's what it's trying to explain to you. It is the corresponding value, positive value. When the absolute value of a number is required, the number is shown in absolute value brackets, and this seems to be a stumbling block that people don't remember. The vertical lines on either side of -2 means absolute value. Anything within those vertical lines is positive. If you have a minus on the outside, it becomes negative again, right? So we have a +2 here that's shown right there. And right in here, we have -2/3 in absolute value brackets, so it becomes +2/3, the corresponding positive value of that, right? And when here we have a +2/3, you just drop the brackets and then you have 2/3. And in here now, we have +2/3 in absolute value bracket with a minus on the outside, so it becomes a -2/3. So be aware of those. When we look at this, just explaining the greater than and less than symbol, the greater than symbol, the arrow is pointing towards the right, and the less than is pointing towards the left. The larger end of the sign indicates the larger number. Okay, so the larger number would be over here, the smaller number would be over here. The smaller number would be over here, the larger number would be over here. When we look at what we have down here, 5, the way that it's read, 5 is greater than larger number 3. When we look at this guy here, 5 is less than 7. Okay, and when we have 3 numbers involved, we will deal with that later on, but it's read a little bit differently. When we look at literal numbers are separated, represented by alpha character. They're usually represented as variables, X, Y, Z, A, B, C, all the alpha characters. Variables, a value that changes and is usually represented by letters of the alphabet, which are literals. Constant, a value that does not change and can be repeated, can be represented by the letter of the alpha K, right? So sometimes it's represented by that, which makes it a literal. When we look at this, literal numbers separate the words of the numbers. So let's look at the example. 5 times a number, right? A number. That number happens to be a variable. It will be an alpha character, which makes it a literal. And then we could write it as 5x, right? When we look at this, this is the literal right there. This is the coefficient, and this is the constant, right? I know that 5 times the number where x is number. Okay, they added on the +2 here, right? So we have a coefficient that's multiplying the variable, and then we have a constant, and those are what they are. Okay. Denominate numbers represent a measurement and are written with units. So when we look at denominate numbers, it means that it comes with a unit. When we look at a temperature of 25 degrees Celsius, right? When we write that as a denominate number, we have 25 degrees Celsius, so it comes with unit, right? So these are denominate numbers. You could have 12 inches, that's a denominate number too, or 250 millimeters, that's a denominate. It comes with units. Every number except in 0 has a reciprocal. Now this term reciprocal, it means division into 1, right? You're dividing it into 1 and then you get the reciprocal. The reciprocal of a number is 1 divided by the number, okay? Or division into 1. right? 1 divided by the number. When we look at 12, we want the reciprocal of 12, we have to divide 12 into 1. And so that's what we're looking at. That's how we get the reciprocal. Why does 0 not have a reciprocal? Because if you were to take reciprocal is usually used to multiply something, and 0, if you multiply anything by 0, it becomes 0. So that's why 0 does not have a reciprocal. When we look at the reciprocal of 5, right, we know that the reciprocal means you're going to divide that number into 1. So this is the fairly simple, 1 divided by 5. That's the reciprocal. When we look at the second one, if we have 1/5 and we want the reciprocal of that, I'm going to go down here and get this pen because I want to explain this a little bit. So we know that the reciprocal means 1. I write it as a fraction, the 1, and I'm dividing it by 1/5. Alright? This is a fraction divided by a fraction, which means that this is 1 divided by 1 multiplied by the upturn and multiply the denominator, and you see that you end up with 5 over 1, which is equal to 5. I'm squishing into the corner here, but that's how you get this number. The reciprocal of a fraction, right? It is divided into 1, and then you work it out, you'll get 5. Okay, so that's where we're at with that. And let's go to the next slide, the next point. Minus 16. The same way that I did this, I know that minus 16 will be minus 1 divided by 16. The reciprocal of that will be minus 16. And right here, if I want the reciprocal of minus the root of 3, I just divide it into 1 and I got it. So those are what we're looking at. And that's the end of this section. I hope that this helps you with your homework, and you should do some exercises. Just do the homework. Don't worry about this, the odd numbers. If you need some extra practice, then the odd numbers there. Don't forget that there's the Washington guide, review guide, also in Learn. Okay, have a great day, and we'll see you for the next one. Bye-bye.